let's have a quick look at this question. Now when it goes write an expression for the gradient of this curve. Well, when you differentiate a exponential function, the differential is the same as the expression here. So when we do dy dx, this stays the same. Exponential function has the same gradient as its function. However, you also got to differentiate this power. The differential of this power is k, and then you got to multiply that by k. So an expression for the gradient will be k times e to the power kx. Okay, now, so we've got this. It goes here, the line L is tangent to this curve at the point x equals 2. And then it goes show that L passes through 0, 0. So let's just do B here. So first of all, we know, as I've explained here, that if y is equal to e to the power half x, dy dx will be equal to, now that stays the same, and then you multiply that by the differential of this power, which is a half. So dy dx is a half e to the power half x. Now, if you got that as your gradient, you want, now it goes here, L is tangent to that at that point. So if that is the function of the gradient at any point x for the tangent, then I can say the gradient of the tangent when x is equal to 2, I put it through here, it's going to be half times e to the power, now this will be a half times 2, which will just equal 1/2 e to the 1, which we can just write as a half e. So that's the gradient. Now, because it is a line, we put it in the form y equals mx plus c, where m is a half e. Now, if that is a point on this curve, okay, where that L is meeting, then if I want to find the y coordinate, I just put the 2 into this. So the y coordinate will also be e. A half times 2 is just 1, so that will be just e. So we know this line, which is L, has a gradient half e and goes through the point 2e. So if I plug those points in, well, let's just put y equals gradient half e, and that's going to be multiplied by x, so that's the gradient times x, plus c. We need to find c, but we know that this line goes through the coordinate 2e, so when that is e, x is 2, so when I put a half, well, a half times 2 is just 1, so that will be just e plus c. Now if I take e away from e, that equals 0, so c equals 0, hence it will go through the origin. So the equation, therefore the equation of the line of L is y equals a half e x, that is it. And when x equals 0, 0 times anything will be 0, so y will equal 0. Therefore, L passes through the origin. Okay, now we come to C, and on C it goes find the coordinates of the point of intersection where this curve and this curve intersect. Okay, so basically that intersects that, y equals that and y equals that, then that is equal to that. So if we are doing simultaneous equations, we can just say 3ex is equal to 1 minus 2e to the half x. And what I'm going to do here, okay, that's fine. So as soon as you see this power is x, this power is half x, you should note that this is a hidden quadratic. So if I say let m equal e to the half x, okay, then this will be 3. Now that power is doubled, so that will be squared, that will become m squared equals 1 minus 2m. So bring everything to one side, so you get 3m squared plus 2m minus 1 equals 0. Now if you factorize this, so you can get 3m, m in here. You can only have 1 and 1 on both sides, but this one is going to be multiplied by 3, and you want a positive, so that's going to be a positive, and that's going to be a negative. So let's just double check it. 3m, let's just say that's 0. 3m times m is m squared. 3m times 1 is plus 3m, minus 1m is going to give me 2m, and minus 1 times plus 1 is minus 1. So I'm happy with that. Now if we got that, also quickly write here that 3m would equal 1, so m would equal 1/3, and in this case m would equal minus 1. Now instead of m, we're going to call it e to the half x, and that is now equal to 1/3. So I'm going to natural log both sides, so ln here, ln here. So that cancels with the e, leaving me half x equals ln of 1/3. And don't forget the x there. And I want the x, so this is being divided by 2, so times it by 2, so x equals 2 ln of 1/3. Now if we want, let's do the y. If we want the y, you plug it in any one of these equations, either that one or that one. I'm just going to put it in this one, just because I know that will go, and then they will cancel. So let's just put it in. Yeah, I'll just put in this one for convenience. So if that is x, y would equal 1 minus, now 2e. Now the power goes, if you do half of x, half of 2 will be just 1, so that will be ln of 1/3. Now e and ln, they are inverse of each other, so they will cancel. So that becomes 1 minus 2 times a third is 2/3. So y would equal 1 take away 2/3, which will give me 1/3. Okay, so this is one of the coordinates where the line is going to find the coordinates. So when x is 1/3, when x is 2 ln of 1/3, y is going to be 1/3 here. Okay. Now, the second point, let's just do that in blue. Let's see. Right, so that's one of the points of intersections. Now, let's see if there's a second point. When m equals -1, we can make e to the half x, which is m, okay, is equal to -1. And now, if you natural log both sides, you'll notice that this can never be the case, okay? If you look at the graph, this can never equal that. But another way, if you natural log both sides, if you log both sides, you can't natural log a negative number, you'll get an error. So on this part, there are no solutions. So when it goes here, find the coordinates of the point of intersection with this curve and this curve. The only point of intersection is this point here. And there's no solutions when that is negative.